This is the key to the worksheet, and this is worksheet number 2 on properties of exponents. And in this worksheet, you're dealing, if you look at all the problems have negative exponents in it. So we're going to look at how to deal with simplifying these expressions when you have negative exponents. So let's go ahead and take a look at number 1. So number 1, we have in the numerator the product a to the 4th times b to the negative 3rd, and in the denominator we have c to the negative 6th power. All right, so when you're simplifying these rational expressions, these expressions, you want to make sure your final answer does not have any negative exponents in it. So you want your exponents to be positive. All right, in order to deal with something like this, you have to remember this property for negative exponents. So if you have b to the negative n power, so if you have some base raised to a negative n power, that is defined to be 1 divided by b to the n power. So these two are the same. So if you're going to make this exponent positive, you're going to have to write it as 1 over b to the negative n. Okay, so that's how this is defined to be. Okay, so knowing this, the best way to deal with this problem is this way. Okay, so think of this. Remember, this is a product right here divided by c to the negative 6. So I'm going to write it like this. I have a to the 4th divided by 1. So a to the 4th divided by 1 times 1 divided by c to the negative 6. And then times b to the negative 3rd divided by 1. So notice that this product, a to the 4th times 1 times b to the negative 3rd, is this numerator. 1 times c to the negative 6 times 1 is this denominator. Okay? All right, so notice that right here I have c to the negative 6. So whenever you have a negative exponent in the denominator, you want to make it positive. So to make that exponent positive, you're going to write it in the numerator. And so we have this. Now, make sure you understand why that's the case. So make sure you understand why this right here that I'm pointing at, this fraction, is the same thing as saying c to the 6 divided by 1. Okay? All right. So let's make sure you understand that. So remember, and we do it this way. So you see this fraction right here, I'm going to rewrite it. 1 divided by c to the negative 6. All right, so remember our property right here. B to the negative n is defined to be 1 over b to the n, right? Okay, so look at this right here. C to the negative 6, let me rearrange this. So we have 1 divided by c to the negative 6 is 1 over c to the 6th power. See this right here? C to the negative 6, b to the negative n is 1 over b to the n. So c to the negative 6, so it's in your denominator, right? So this expression is 1 over c to the 6. Now remember, when dividing fractions, you take the numerator, the fraction in the numerator, and you multiply it by the reciprocal of the denominator. So 1 divided by c to the 6 is c to the 6 divided by 1. And so 1 times c to the 6 is c to the 6, and then in the denominator you have 1. So this right here, 1 divided by c to the negative 6 is c to the 6 divided by 1. Okay? So that's what we have here. So what most students remember about this is this. If the exponent is negative in the denominator, whatever is being raised to the negative power, you're going to bring it to the numerator, and that exponent becomes positive. And same idea here. If it's negative in the numerator, you're going to take whatever's being raised to negative power and bring it to the denominator. All right, so for example, we have b to the negative 3rd divided by 1. Right, b to the negative 3rd divided by 1. All right, so by definition, the numerator is 1 divided by b to the 3rd divided by 1, right? And so I'm going to take the fraction in the numerator, 1 divided by b to the 3rd, multiplied by the reciprocal of the denominator. The reciprocal of 1 is 1 divided by 1. And notice 1 times 1 is 1. B to the 3rd times 1 is b to the 3rd. And notice this right here is what we will have, times is what we're going to have here. Okay? All right, so just remember, If it's negative in the denominator, you're going to bring it to the numerator. If it's negative in the numerator, to make that exponent positive, you bring it to the denominator. And the reason for all that is what we just talked about here. And all we did was use this property in each of these situations. C to the negative 6 is 1 divided by c to the 6, and then I used knowledge from a previous course. When dividing fractions, you change the multiplication problem. The fraction in the numerator times the reciprocal of the fraction in the denominator. Okay, same thing here. Okay, so now don't leave your answer like this, though. You got to write it as one fraction. That's important. That was one of the things you learned when simplifying these expressions. So you're going to say a to the 4th times c to the 6th times 1 is a to the 4th times c to the 6th. And then 1 times b to the 3rd power is b to the 3rd power. Okay? All right, so let's look at number 2. So number 2, we have x to the 4th times x to the negative 9th divided by x squared. All right, now notice that straight off in that numerator, I'm multiplying like bases, right? Multiplying like bases. So I can use the product rule for exponents. So when I multiply like bases, I add exponents. So the first thing I would do is use the product rule here. So x to the 4th times x to the negative 9th is x to the 4 plus negative 9 is a negative 5 divided by x squared. And now notice the quotient rule, right? Now I can use a quotient rule. So the quotient rule says when you divide like bases, you subtract exponents. So this becomes x to the negative 5th minus 2. And so that's x to the negative 7. All right, now remember, you don't want your answer with negative exponents. So we're going to use this property that b to the negative n is 1 over b to the n. So x to the negative 7th is 1 divided by x to the 7th. And there's your answer. All right, so that's number 2. Number 3, we have a to the 6th divided by x cubed times x to the negative 3rd times y to the negative 5th. So there's quite a few negative exponents here, but what I want you to remember, what I want you to see this one right here. I'm going to go ahead and rewrite it so I can circle it. So I have a to the 6th times the x to the 3rd times x to the negative 3rd times y to the negative 5th. All right. Before I even use this property right here, I want you to notice something. Right here, you're multiplying like bases, right? So I can use a product rule right away. So when I use a product rule, this becomes a to the 6th divided by x. Now remember, when you multiply like bases, you add exponents. So product rule for exponents, 3 plus the negative 3 is 0, right? So that's 0. So that's x to the 0 power times y to the negative 5th. But remember, one of the other properties you learned in this lesson was that when you have the base raised to a 0 power, as long as the base is not 0, so x is 0 power, that's defined to be 1. So this right here is just 1. And 1 times y to the negative 5 in the denominator is y to the negative 5. So that's where we're at. So don't think that's your final answer, because remember, when simplifying these expressions, you don't want negative exponents in your final answer. So I'm going to rewrite this one just like I did this one, just to show you. Now, most of you know right away, hey, I have a negative exponent in the denominator. So to make that exponent positive, I got to bring that to the numerator, right? So let's look at this. So I'm going to rewrite this as a to the 6th divided by 1 times 1 divided by y to the negative 5th. So this right here is this product. So now I know that y to the negative 5th, to make that exponent positive, I'm going to have to rewrite this as a to the 6th divided by 1 times y to the 5th divided by 1. So this expression is the same as this. Now I want to mention something. Some students confuse what I did here. So some students think that all you do is take the reciprocal of this fraction. That's not true. So it's very important you understand what's happening here. So the reason why this is because of this. So remember, 1 divided by y to the negative 5th, right? So I'm looking at this denominator right here. That's the one that's negative. So So the numerator is 1, so that's where this 1 is. The denominator, I know by definition, that's 1 divided by y to the 5th. And now I'm going to use a property from previous course that when you divide fractions, you take the fraction that's in the numerator multiplied by the reciprocal that's in the denominator. All right, so the reciprocal 1 divided by y to the 5th is y to the 5th divided by 1. And so this 1 you see here is not from here. Okay, see this 1 right here? This 1? This 1 is this 1. That is not from here, but from here. Okay, so that's important you see that. So that's y to the 5th divided by 1. So that's where this comes from. So the idea being this, if I had 2 divided by y to the negative 5th instead of 1, if I had 2, don't say the answer is y to the 5th divided by 2. That's not true. You're not taking the reciprocal. It's important that you see that. Okay, so that's not a true statement. This right here is actually this. It's 2y to the 5th. That's what that is. So 2 divided by y to the negative 5th is 2 times y to the 5th. So let's go ahead and do it this way so you can see why that's true. Why is this, and not this? So don't confuse the fact that, don't think I'm taking the reciprocal of this fraction. That's not what's happening. All right, you're looking at, let me show you again. You're looking at this right here, okay? This right here, that's in the denominator. So this 2 is in the numerator. By definition, y to the negative 5th is 1 divided by y to the 5th, okay? So now I'm going to divide those two fractions. I'm going to change the division to multiplication. So I take the fractions in the numerator, 2, times the reciprocal of the denominator, which is y to the 5th divided by 1. And notice 2 times y to the 5th divided by 1 is 2y to the 5th. All right, so it's important you understand that this is not taking the reciprocal. All right, so please be careful. That's not what's happening. That's a mistake that many students make. So this is not the so this right here is not the reciprocal of this. Okay. All right, so I get a to the 6th times y to the 5th divided by 1. Don't leave it like this. I expect you to know that a to the 6th times y to the 5th divided by 1. Anything divided by 1 is that numerator, right? So there's your answer. Okay, so a to the 6th times y to the 5th. Okay, number 4. So let's look at number 4. All right, number 4, we have this problem. All right, we have 2u to the 3rd power v squared, all raised to the negative 3rd power. Okay? All right, now, there are a couple approaches you can take. So let's do this first approach first. So remember, when you take the power of a product, remember the power of a product rule? So according to the power of a product rule, I can take each of those factors and raise to that product. So that's what the power of a product rule states. So I have 2 to the negative 3rd times u cubed to the negative 3rd times v squared to the negative 3rd. All right, so each of these is being raised to the negative 3rd. Okay, now remember, 2 to the negative 3rd, so I have this idea here. So 2 to the negative 3rd by definition is 1 divided by 2 to the 3rd. Okay, now let's go ahead and remember your power of a power rule. So I have the u to the 3rd raised to the negative 3rd, so 3 times negative 3 is negative 9, right? And then v squared raised to the negative 3rd power, 2 times negative 3 is negative 6. So let's go ahead and make these positive. So I'm just using, to do that, I'm using this definition. So I get 1 over 2 cubed is 8, right? Times 1 divided by u to the 9th times 1 divided by v to the 6th. Okay? And so now let's write this as one fraction. Don't leave it like this. 1 times 1 times 1 is 1. 8 u to the 9th, v to the 6th. All right? So that is the most effective way to do that based on your your knowledge of all these properties, all the properties you've learned. Okay? All right. Now, another way that some students will do this is this way. Okay. Now remember, the way I just did it is the most conceptual one, because you know all those properties. You know that the power of a product, you take each of those factors, raise that power, and then to make this exponent positive, I'm going to use the definition here, and so u to the negative third is 1 over 2 to the negative third is 1 over 2 to the third, and then your power rule. 3 times negative 3 is negative 9, 2 times negative 3 is negative 6, and now use this rule again with these. Okay? But here's what some students will do. So if your outer exponent, whenever you have a power to a power of a product and that exponent is negative, to make that exponent positive, you just take the reciprocal of this. So watch what happens. So 2u to the third v squared raised to the negative third. So if I'm going to make this exponent positive, I'm going to take the reciprocal of this. So that becomes 1 divided by 2u cubed v squared, all raised to the third power. Okay? Now remember, this 1 here is actually from here. All right. So to make that exponent on the outside positive, you take the reciprocal. And then we're going to take the power of a quotient. So here I took the power of a product. Here I'm going to take the power of a quotient. So I get 1 to the third power. So remember, the power of a quotient, you're going to take the numerator raised to that power, take the denominator raised to that power, divided by 2u cubed v squared to the third. All right. Now 1 to the third is 1. So this one is this one right here. And then you're going to take, so now you have a power of a product, right? Power of a product. So you're going to take each of those factors, raise it to that third power. So 2 to the third, u cubed to the third, and then v squared to the third. And then simplifying this, I get 1 divided by 2 cubed is 8, u to the third power raised to the third, so 3 times 3 is 9. And then the power rule here, 2 times 3 is 6. All right, and so notice this answer is the same as this. But the most conceptual one for you is this, because all the properties you've learned involves this. Okay, so doing all this involves those properties you learned. This is a little bit more not intuitive as to, well, why do I take the reciprocal to make that outer exponent positive? All right, so if I were you, though, I would go ahead and do it this way, because those are the properties you know about. All right, so let's look at number 5. So number 5, we have this. For number 5, we have w to the negative 6 times w to the third raised to the negative fourth, all divided by w to the fourth. So I have a lot of w's here, right? Okay, so you see I have this parentheses right here. So let's kind of deal with that parentheses. Let's see if I can remove that parentheses right away. So here I'm going to use a power rule. So I have w to the negative 6 times, and then 3 times negative 4 is negative 12, all divided by w to the fourth. And now this looks like one we did earlier. So it kind of looks like number 2 now, right? So let me remind you what number 2 was. So here's, you see this right here, looks like this now. See it? Okay. So what we're going to do now is use the product rule. So when you multiply like bases, you add exponents. So this becomes w, negative 6 and a negative 12 is a negative 18 divided by w to the fourth. And I'm going to use the quotient rule. And so when you divide like bases, you subtract exponents. That becomes w to the negative 18, subtract 4, which becomes w to the negative 22nd power, right? And now we're going to use our negative exponent rule. So b to the negative n, w to the negative 22 is 1 over b to the n. So 1 over 1 divided by w to the 22nd power. All right? So always make sure that your answers are simplified and there are no negative exponents. Number 6. And number 6, we have in the numerator, we have 3xy cubed to the 0 power divided by 5x squared y to negative second. Okay? All right. Now, right away, don't make this complicated. You have this whole product here being raised to the 0 power. So remember our 0 exponent rule. Whenever you have the base that's being raised to the 0 power, that by definition, that's understood to be 1. So all of this is being raised to the 0 power. So that's 1. Right away, the numerator is 1. And I'm going to go ahead and rewrite the denominator. And what I'm going to do now is think about what we just said. So I need to make this exponent positive. It's in the denominator, so I'm going to have to bring this to the numerator. So the answer is going to be, in the numerator, you're going to have this one is this one times y squared. Okay, 1 times y squared divided by 5x squared. And so 1 times y squared is y squared divided by 5x squared. So that's the answer there. But let me just remind you, I'm going to do it the way we've been doing it since we started with number 1. So what I would do is I would think of it this way. 1 divided by 5 times 1 divided by x squared times 1 divided by y to negative second, right? Okay. So 1 times 1 times 1 is 1, and then all this in the denominator multiplied together is this denominator. So to make this exponent positive, it becomes 1 divided by 5 times 1 divided by x squared times y squared divided by 1. Now remember what we said, don't think that this here is a reciprocal of this fraction. That's not true, right? So this 1 is not this 1. So remember what we said. So it's important you see this. So remember this 1 is not this 1. Okay? So where we had 1 divided by y to negative second, it's important you understand this. So in the numerator, this one's this 1. Now, by definition, y to negative second is 1 divided by y to the second. And now we're going to change this to a multiplication problem. So you take the numerator, multiply by the reciprocal of the denominator. So the reciprocal of 1 over y squared is y squared divided by 1. And so 1 times y squared is y squared divided by 1. So this 1 here is this 1 which came from this, not this. Okay? All right, it's important you see this. See, this 1 is this right here. Okay? This 1 is this. So be careful. Don't think that this is that this right here is reciprocal of this. Okay? That brings us back to what we saw here, right? So the answer is not the reciprocal of this. So you got to be careful. When you do a negative exponent, it's sometimes if you're not understanding it well, you tend to make that mistake where you think to make this exponent positive, I take the reciprocal of this fraction. That's not true. Okay? And we saw why that's not true here. Okay. And so now I'm going to rewrite this as one fraction. 1 times y squared is y squared. And then 5 times x squared times 1 is 5x squared. And so that's the answer to number 6. Okay? And then finally, number 7. And in number 7, we have in the numerator, we have x squared y raised to the negative 4th power. Let me rewrite this. So this was number 7. We have x squared y divided by y to negative 3rd, all raised to the negative 4th power. So I'm going to do it the most intuitive way based on the properties you know. So I know that I'm taking the power of a quotient, right? Power of a quotient. So what I'm going to do is I'm going to take the power of the numerator. So my numerator is x squared y. I'm going to raise it to the negative 4th power. I'm going to take the denominator, y to the negative 3rd, and raise it to the negative 4th power as well. Okay? All right, now over here, I'm taking the power of a product. So now this becomes x squared to the negative fourth power times y to the negative fourth power, right? And so now in the denominator, the power rule, negative 3 times negative 4 is 12, so it becomes y to the 12th. Okay, now let's go ahead and use a power rule here. 2 times negative 4 is negative 8, so I get x to the negative 8 times, and then y to the negative 4th divided by y to the 12th. Okay, so that's where I'm at. Okay, now what I want you to see here is that here you're dividing like bases, right? So I'm going to use the quotient rule. So we divide like bases, subtract exponents. Make sure you see this. Make sure you see that this right here is x to the negative 8 divided by 1 times y to the negative 4th divided by y to the 12th. Okay? And so this becomes x to the negative 8 divided by 1 times divide like bases, subtract exponents. So that's times y to the negative 4 minus 12. Right? And so then this becomes x to the negative 8 times y to the negative 4 to negative 12 is a negative 16. And then using the negative exponent rule, x to the negative 8 is 1 over x to the 8th times y to the negative 16th is 1 over y to the 16th. And writing this as one fraction, 1 times 1 is 1. And then we get x to the 8th times y to the 16th. And so that's the answer there. Okay? All right, now I'm going to do number 7 again, but I want you to see what else you could have done. Okay, so number 7, so this is number 7 again. So we have x squared y divided by y to the negative 3rd raised to the negative 4th. So you remember what I did was I first of all I used the power of a quotient rule, and so that's how I got this. What you could have done first was notice, hey, I'm dividing like bases, so could I have used the quotient rule first? Sure. So we have y divided by y to the negative 3rd, right? Y'all agree? Okay, so that's y to the 1st. This is this. This is this. So when you divide like base, you subtract exponents. So I get y to the 1st minus a negative 3. Make sure you write this correctly. The exponent in the numerator subtract the exponent of the denominator. And then 1 subtract a negative 3 means 1 plus the opposite of negative 3. So that becomes 1 plus 3, which is 4. So that's going to be so this right here is this. So I get x squared y to the 4th raised to the negative 4. See that? Now I'm going to use the power of a product rule. So this becomes x squared, that's a 2, raised to the negative 4 times y to the 4th raised to the negative 4. And then using a power rule, 2 times negative 4 is negative 8. So I get x to the negative 8. And then 4 times negative 4 is negative 16. And notice this right here is this, right? So now this approach took us a little bit longer because we had more properties to use. Whereas if I would have done the quotient rule first, then I could have gotten the answer quick. Now that's not the answer because remember you can't have negative exponents. So the negative exponent rule says x to the negative 8 means 1 over x to the 8th, 1 divided by x to the 8th, and then y to the negative 16th means 1 divided by y to the 16th. And then as one fraction, 1 times 1 is 1, and then x to the 8th times y to the 16th. Okay? And so that is number 7. So notice that depending on the properties you learn, you can do some of these problems in different ways and still end up, as long as it's mathematically correct, still end up with the correct answer. Okay? So that is the key. That is the key to let's see. That is the key to this worksheet. All right, so there's the key.